Hi everyone, welcome to my channel Chemistry Cracker. Today we're going to solve some typical exam style questions on the topic chemical bonding. So I collected very common questions on this topic, so we'll solve them together and I'll show you typical mistakes and some keywords to use to answer some questions. So let's begin from the first question. So usually in this topic, in chemical bonding, you need to define different types of bond and different terms. So first of all, you can see the definition of the term ionic bond, and there is only 1 mark awarded for that question. Sometimes you may have 1 to 3 marks for just one single definition, and you need to understand what bullet points should you provide in your answer. So according to the definition, ionic bond is an electrostatic attraction. So it's electrostatic attraction between positively and negatively charged ions. These seem to be correct, but one thing is still missing in the definition. So the way ions form is not explained in its definition, so these must be provided. And how these ions are produced? Ions are produced due to transfer of electron from one atom to another. That's how ionic bond is formed. So full definition should look like that. It's an electrostatic attraction between positively and negatively charged ions produced during transfer of electrons. So that's how your definition should look like. Let's move on to the next question. So it's part B. Explain why ionic compounds are non-conductor of electricity in solid state but conducts electricity in molten state. So you need to refer to the lattice first of all. So you should explain that in solid state ions, so they are in fixed positions, while in molten state they are mobile. So there are 2 requirements for any material to be an electrical conductor. So first requirement is having charged particles. So these could be ions, doesn't matter, positive, negative, or both, or electrons. And second condition, so those must be mobile. So they shouldn't be in fixed positions, they must be able to move. And this makes any material an electrical conductor. So this also can be applied to a molten state or to an aqueous state of any conductor. So in this question you need to relate to these conditions. If one of them is not followed, it means your material is not a conductor. So you need to say that. So in solid state, ions fixed, while in molten they are mobile. So as you see, there are 2 bullet points, and this question gives you 2 marks. Let's move on to the next question. So next part of the first question, part C. Ionic compounds are brittle and can easily be cleaved apart. Suggested a reason for this. Well, again, you need to refer to the structure, and you need to forecast what may happen if you put some force, put some effort to the lattice. So we can show this structure using that representation. So in ionic lattice you have ions of positive and negative particles in that way. So it's just a tiny part of a huge structure. So you see that they are going one by one, so positive to negative, positive to negative. And these ions are held together by very strong electrostatic attraction forces. But when you hammer, for example, so you're hammering it, so imagine this is a hammer, so you're hammering it, so you need to deduce what may happen if you hammer it. So when you hammer it, your layers may slide in this way. So in that case, I'm still representing same combination of ions. So one layer has slided on another layer. As you see now, ions with the same charge, so positive to positive, negative to negative, are now close to each other, and you know that there are repulsive forces between them, so this results in breaking the lattice right in that place. So you have just two pieces of initial structure. So now you just cleaved apart these structures. So that's what you need to represent in your explanation. So just use 2 bullet points, look at the question, how many marks awarded for this answer. So you need to describe this effect. You can actually draw it and just add some details, maybe using just 1 or 2 sentences to simply explain that effect. Let's move on to the next question, question number 2. So this is about formation of dative bonds, shapes of molecule, etc. So ammonia is a covalent compound that forms coordinate bonds with other molecules. Just a story before the question. Draw the structure of ammonia molecule, denote its shape and number of bonding pairs and lone pairs of electrons. Alright, so first of all we need to memorize that ammonia is an H3, and then we need to understand what atom is a central. So obviously nitrogen is a central atom, and we need to memorize how many electrons are there. So ammonia is located in group 5, so it means that it has 5 electrons in the last shell. Actually there are 7 electrons in total, so first electron consists of 2. So first layer consists of 2 electrons, so there are 5 electrons here, and there are single bonds with hydrogen atoms, with 3 hydrogen atoms around nitrogen. So now we have 3 electrons used in formation of the covalent bond, so here they are, and 2 left unused, and we must show them as a lone pair of electrons. Now we need to show its shape, or just write it down, what shape is it, and number of bonding pairs and lone pair of electrons. So you need to write here, so there is 1 lone pair of electrons and 3 bonding pairs of electrons. So these may be just 1 mark just for mentioning this. So lone pair is 1. Okay, then you need to tell what type of shape does it have. So you should remember that a combination of 3 bonding pairs and 1 lone pair results in that kind of structure. So we just simply name it trigonal pyramidal. So it's trigonal pyramid. So this is a full answer that gives you 3 marks for this question. Let's move on to the next part. So we need to also say what what is the value of bond angle? You simply need to memorize that bond angle in this case is just 107 degrees. Now you need to explain how coordinate bond is formed. So coordinate bond is formed when one atom provides a pair of electrons to make a covalent bond. So the main important part is this. So just one atom provides a pair of electrons. Usually typical covalent bond is made when one atom shares one electron, another shares one more electron. So that is how typical covalent bond is formed. But in case of coordinate bond, one single atom provides both electrons and another atom comes with no any electrons. So in this case it's hydrogen ion. Now in next part they are asking about these coordinate bond formations. So you need to explain how ammonium ion is formed. So ammonium ion is NH4 plus ion, so it can be made by the reaction between NH3 and hydrogen ion to form this ion. So you need to describe it, and as you see it gives you 3 marks. This is not enough, so you need to describe it by words. So you need to say that in ammonia molecule, nitrogen atom provides lone pair of electrons. You remember that in ammonia we have that lone pair can be used in production of these coordinate bond, and this lone pair of electrons is provided to hydrogen ion, and as a result you have that type of ion. Now we need to show its structure, and we need to use just a displayed formula. We are not asked about 3D formula, so the task is simpler now. So in ammonium ion, as you remember, we have ammonia and hydrogen ion, so it's just a proton with no electrons, and you are asked to show coordinate bond by an arrow. So you must remember that in coordinate bond, arrow is always directed from an atom donating pair of electrons. So if you show something like that, this will be wrong answer. So this matters. So arrow should be directed from nitrogen, because nitrogen provides that pair of electrons. And for this you can get 2 marks, probably for mentioning all of these combinations of atoms. And one more thing is left to cover, so you need to put this in the brackets and show the total charge plus. So if you forget to do that, so you probably will have just 1 mark for your answer. Then you need to answer what's the shape of ammonium ion. So you see it's just combination of 4 bonding pairs of electrons, and from valence shell electron pair repulsion theory, you should remember that this combination, when you have 4 bonding pairs, no lone pairs, this is a case of the tetrahedral shape. Okay, let's move on to question number 3. As I mentioned before, you will be often asked to define some terms, and now it's time to define the term electronegativity, and this gives you 2 marks maximum. So electronegativity, so you may find different definitions of this term, but mostly they consider same thing, which is an ability of an atom to attract pair of electrons in a bond. So how can you get these 2 marks? So first of all, you need to mention that it's an ability of an atom to attract something. So it's an ability of an atom, of an element, to attract. To attract bonding pairs. So this is also makes big sense. So bonding pairs of electrons. So that is your second mark. So often students do that mistake, just mentioning pairs of electrons without mentioning that it's just a bonding pair of electrons. It makes a big difference. So please be careful when answering these kind of questions. So that gives you 2 marks. All right, next part, this is about bond polarity. So bond polarity is a case when 2 atoms of a different electronegativity are binded covalently, and usually one atom is more electrically negative and another is less, and this results in production of partial charge. As you see, it's delta plus, delta minus here, so you need to use that to denote the polarity of a bond. So you simply need to find these values here. So it's just a Pauli electronegativity scale. So use that electronegativities to predict which atom, to find out which atom is more electronegative, and assign partial charges appropriately. So first case, hydrogen and carbon. You see carbon is a bit more electronegative, so this will result in partial negative charge on it and partial positive charge on the hydrogen atom. Same should be done with the next pair of atoms. So fluorine is more electronegative, sulfur is less electronegative. And the last one, carbon and bromine. So bromine is more electronegative and carbon is less electronegative, and that results in that distribution of partial charges. So this is just for 2 marks. Next question related to molecule polarity. So it's a bit different from bond polarity. So in case of bond polarity, it's very obvious. You just need to relate to the electronegativities of each atom. So first of all, you need to come up with the shape of the molecule. So the shape is tetrahedral shape, and you can find from previous task values of electronegativity. So chlorine is more electronegative than carbon, so chlorine atoms will attract all of the electron pairs from carbon atom towards themselves. So this looks like that if we show how electrons are distributed in a molecule. But because of the symmetry, so you should remember that tetrahedral structure is kind of symmetrical shape. So because of symmetry, this electron distribution in a molecule is equal. So this can be related to the ideas of vectors in math. So all of these vectors, they cancel each out together in the molecule, and there is no dipole momentum in this molecule. So this gives you 2 marks and 1 mark for explanation of the zero net dipole momentum. Next question is about intermolecular forces, which is still in that unit. So you have a very typical question about changing of some properties of compounds. So it's for hydrogen halides, so group 7 elements, and their boiling points change. So first is to explain how it changes from HCl, this part, to hydrogen iodide. So there are several factors affecting to this property, so don't be confused, and explain it using appropriate one. So what changes between these elements? So we simply have a bigger atom downwards, so it's just we're just going down by group from chlorine to iodine, and substance with a higher boiling point means it has stronger intermolecular forces, and you need to specify that in your answer. And the second mark is awarded for explanation what type of forces are there resulting in that difference in boiling points. So you need to simply say that, well, first of all, what kind of forces are present here in these molecules. So there are two types of forces present. So first is just dipole-dipole interactions, because we simply have a molecule with two atoms of different electronegativities, and there are partial charges, and molecules of the same compound can be attracted to each other. Same in hydrogen iodide. So you may say that dipole-dipole forces in hydrogen iodide are stronger, but in fact this is not true, and this will ruin your answer, so you won't get any points for that. So don't mention dipole-dipole forces, permanent dipole-dipole forces. We're talking about permanent dipole-dipole interactions. So don't mention them because the answer is actually explained by another type of force. So first type of force, as I mentioned, is permanent dipole-dipole interactions. Second type of forces is present in all of the molecular compounds, and it's known in general London forces or London dispersion forces, which is the same. So down the group from chlorine to iodine, you simply have more electrons. As you remember, down the group we have more shells, and here we have more electrons, meaning that instantaneous or induced dipole-dipole forces are way much stronger, just simply because of greater number of electrons going down by groups. So you need to say that London forces in hydrogen iodide are stronger compared to hydrogen chloride. And you need to explain why. So this gives you just one mark, and why these forces are stronger in hydrogen iodide, because iodine has more electrons, and well, this explains that. So this gives you 2 marks. So students, be careful answering these kind of questions. This may be a very tricky question, and you can easily make some mistakes. Next question: why the boiling point of hydrogen fluoride is greater than other hydrogen halides? So as you see, we see some deviation from a general trend. So this, according to our prediction, should be somewhere here, but in fact it's way much greater, and this is explained by, again, mentioning the type of forces present between these molecules. So what kind of forces are present there? So everywhere we have, again, London forces, but if you use this to explain your answer, you'll get 0, because in this case London forces are really weak in hydrogen fluoride compared to others. So this means that hydrogen fluoride must have lower boiling points. And the second type of force is hydrogen bonding present in hydrogen fluoride. So you need to mention this. This will give you 1 mark, and you need to mention that so this does not give you any marks, so you need to mention that in other halides there is permanent dipole forces. And you need to mention that hydrogen bonding is stronger. So your answer must be comparative, and finally this gives you a full mark. Next, why does the boiling point of hydrocarbons increase with increase in number of carbon atoms? Again, we refer to London forces. Become stronger with more electrons. So this and comparative answer gives you a full mark. Next part, why is the boiling point of straight chain alkanes higher than boiling points of branched alkanes with same number of carbon atoms? So in order to explain this, we need to come up with some examples. So let's take pentane and its isomer, or let's say butane and its isomer. I'm not showing a whole structure, but let's assume that, well, let's just quickly show the structure itself. So this is a butane, and I'm showing another butane molecule right under this molecule. And now let's draw an isomer of this molecule, which is isobutane or methyl butane. And I'm going to draw a next molecule of the same compound like that. So only London dispersion forces are present here. So you need to explain how they differ in the compounds with same molecular formula, so you don't have different number of electrons. And in this case, you need to refer to the idea of the contact points between molecules. So in these parts, molecules could be attracted to each other because of some instantaneous or induced dipoles in both molecules. So the maximum number of contact points in this case, it's not 5, it's 4 for this molecule. So for straight chain alkane. But for a branched one, it's always less. As you see, the maximum contact points number is less, so it's 3. And this explains why isomers have lower boiling and melting points. So explain it using that idea and you'll get the full mark. All right. Okay, next question, question number 5. So as I told you before, sometimes you need to define some types of bonds. So you need to explain what is metallic bonding, show it's using some diagrams, and define it. So you should remember that any metal has a lattice, so it's just a part of the lattice. In the lattice we have some particles held together by some types of forces. In metallic bonding we have positive metal ions and the sea of electrons. So be careful with the number of ions and electrons. So you must show the sufficient amount of electrons that result in zero charge of the structure. So as you see now, I have 9 ions shown, so it means that there must be also 9 electrons. So examiner may be sitting and counting your electron amount. So 3, 4, 5, 6, 7, 8 and 9. And also don't forget to label it. So it's just electrons, and these are metal ions. And you need to explain that type of bond, giving its definition. So as you see, this question gives you 3 marks maximum for the property definition. So it's again electrostatic attraction. Between particles mentioned above. So between this and this. So this gives you a full mark. So first is just for electrostatic attraction, and second for type of particles present in the lattice. Next, this question is related to properties of metals, so you need to explain why metals can conduct electricity. So as you see, this gives you 2 marks. So first of all, you need to relate to the idea of having charged mobile particles. So you need to see that metal lattice has metal lattice has the C of mobile or delocalized electrons. And when you just apply some terminals, electrons may flow from one part to another. So you're just simply describing the current flow. So that is the second mark for this question. Next question is related to the melting point. So relatively, metals mostly have high melting points, and you need to explain why it's so. So when you have that property, you need to relate again to the lattice. So explain that lattice is strong and explain why it's strong. And you need to say that electrostatic attraction forces or metallic bond is strong. And second part is for just giving an idea that it's hard to break that structure and requires more energy to overcome attractive forces between particles mentioned above. Next question is about properties and trends of metals. So you need to explain why magnesium conducts electricity better than sodium. So in order to answer to that question, you need to know the structure, the electronic configuration of magnesium and sodium. So these two metals, they belong to group 3, to period 3, but different groups. So their electronic configuration is 282, 281. And you should remember how metallic lattice is formed. So it's formed when electrons are lost by metal atoms to produce metal ions. And as you see, all of the electrons from the last shell are lost for that. And in case of magnesium, you simply have more electrons that are donated by a magnesium atom to the sea of electrons, and it means that there are more particles that can carry the charge. So simply explain it using that idea and you'll get the whole mark. Next property is about metals located in the same group. So the question is about beryllium and calcium. So these metals belong to group 2 but different periods. So their electronic configuration is 2 and 2, and for calcium is 2882. They still donate same number of electrons to the sea of electrons. So it has no sense to explain the better electrical conductivity of calcium just mentioning the number of electrons, because as you see, it's same. Then it means you need to relate to the ions present in the lattice and compare them and deduce how can this impact on the electrical conductivity. So beryllium and calcium differ by charge density. So this ion is big. Big ion means charge density is very low. It's lower than in beryllium ion. Therefore, it means that calcium easily loses that electrons to donate them to the sea of electrons, and calcium should have better electrical conductivity. So 3 marks awarded for first comparing the size of ions, then mentioning lower charge density in calcium ion, and finally summing up that this in total results in better conductivity of calcium as a metal. Next question is about intermolecular forces and some properties of water, some unique anomalous properties of water. So we need to explain why ice is less dense than liquid form of water. So again, you need to compare states of matter of the same compound in different aggregate states. So liquid water is described by water molecules located very close to each other, but able to move within themselves. So this is a liquid state. And we need to mention what happens when we solidify water to produce an ice. So in order to explain that, we need to draw the shape of water molecules and explain what may happen between water molecules. As you remember, there is a hydrogen bond between partially positive, partially negative oxygen and hydrogen atoms in water molecule. And because of that, when water solidifies, hydrogen bonds they result in some certain type of lattice. So it's kind of a honeycomb structure with water molecules everywhere. So it's just a part of the huge fragment. And so these are oxygen atoms, oxygen. And as you see, there are some empty spaces between water molecules. And as you remember, density is expressed as mass divided by volume. So same mass, it means same number of water molecules, occupies different volume. In that case, it occupies that volume in liquid form, but in form of ice, it will be bigger because hydrogen bonds, they have some bond length which is greater than bond lengths between atoms of hydrogen and oxygen in water molecules, and they're a bit further from each other rather than in liquid form. And that could be explained to get a full mark for this very common question. Next question is related to that abnormality properties of water. So what are these properties of water? So as you see, this question gives you 2 marks. But be careful here because you already have one of the properties mentioned above. Don't list it one more time because this will not give you any marks. So you can pick up any of these options. So water has higher melting points or boiling points. Then water has higher viscosity. Or you can add some more options in case if you're not sure that one of the properties are definitely abnormal, so you can give something additional and maybe examiner will take them as a correct answer. But be careful, don't put answers that contradict to each other, because examiner may just write that there is a contradiction in your answers and reduce your total mark. So in addition to these two properties, you can also say that water has higher surface tension. You probably remember that facts about some insects able to move on the water without drowning it. So next question about ethanol properties and what can happen between ethanol and water. So structure of ethanol is given, and what may happen or what must these two particles, two molecules have in order to have or form hydrogen bond between them. So you need to say that one atom, so oxygen, must have lone pairs of electrons and must be binded to hydrogen atom. And in water, so this is in alcohol part, and in H2O you must have there must be partial positive, partial negative charges on hydrogen and oxygen molecules. So and these two parts of two molecules can be attracted to each other. Next question, you need to explain it using a diagram. So you need to draw a structure of alcohol and water, as I mentioned before. So delta minus here, delta plus here, and water molecule. So we have hydrogen, oxygen, hydrogen. Don't forget to put the partial charges and show formation of these hydrogen bonding between them. So this gives you a full mark for this question. So that's it. This was a guide into common exam style questions in topic chemical bonding. So please like, share and comment if you want to get more lessons like that, and do your best in your A-level exams.